Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
The question is f of x is equal to e raised kx minus 1 bracket complete into sine of kx whole thing divided by x square comma x not equal to 0 and is equal to 4 comma x equal to 0 at indicated point x equal to 0. So in this question we have given the function f of x is continuous at x equal to 0, and by using that fact we have to find the value of unknown term, that is k. So now let's see the solution. First of all, given f of x is continuous at x equal to 0. Therefore, by using first definition of continuity, that limit x tends to 0, f of x is equal to f of 0. Therefore, limit x tends to 0. Now x tends to 0 means x not equal to 0. And for x not equal to 0, we have f of x is equal to e raised kx minus 1 bracket complete into sine of kx whole thing divided by x square. That equal to, now f of 0 means x equal to 0, and for that purpose f of x is equal to 4. Now here, to solve the limit problem, we have to use the two rules of limits. Number one is limit x tends to 0 e raised x minus 1 upon x, so that equal to log of e, and that equal to 1. And secondly, limit x tends to 0 sine of x upon x is equal to 1. So in present case, we write limit x tends to 0 e raised kx minus 1 whole thing divided by x into limit x tends to 0 sine of kx upon x, and that equal to 4. Therefore, the next step will be limit x tends to 0 e raised kx minus 1 upon kx into k. It means here multiply numerator and denominator by k into limit x tends to 0 sine of kx upon kx into k, and that equal to 4. Here also we divide numerator and denominator by k. So the next step will be limit x tends to 0 e raised kx minus 1 upon kx, that gives 1 into k, into limit x tends to 0 sine of kx upon kx, that again gives 1 into k is equal to 4. So therefore k into k, that is k square, is equal to 4. Taking square root on both sides, so we have k equal to plus or minus 2. So in this way we get the value of k. So this is a required solution for the given problem. Thank you.